Welcome back to the deep dive. We are pulling a complex corporate giant out of the ground today.
Oh, really are.
We are cracking open the history, the strategy, and what I think is a massive internal pivot of Baker Hughes Company.
Mm-hmm. And when you hear that name, you likely picture the rugged world of, deep oil and gas drilling.
And you would be right.
For the most part. But the modern strategic map of this company looks radically different from its legacy.
That's it. That's the core mission of this deep dive. We're going to trace the century-plus history of this global energy technology powerhouse.
Right, and analyze how constant, often aggressive mergers and acquisitions built its current identity.
And most importantly, I think, understand its dual organizational focus.
Exactly. It's split between the traditional oil services and this unprecedented push into new energy technologies like carbon capture, hydrogen, and even geothermal.
Exactly. So this isn't just a corporate history lesson. This is a blueprint for corporate adaptation on a truly immense scale.
It really is.
Okay, so let's unpack this with some quick context. We're looking at a Fortune 500 company. It's co-headquartered in Houston, Texas.
The heart of the oil patch.
And London, UK, which I think reflects its global and increasingly European energy transition focus.
That's a great point. And it's a major component of both the NASDAQ 100 and the S&P 500.
And you have to appreciate the sheer scale of the operation we're discussing here.
Absolutely. For 2024, the company recorded a revenue of US $27.83 billion.
Wow.
And they employ approximately 57,000 people globally. They're operating facilities and service locations in over 120 countries.
So everywhere.
Basically everywhere, stretching across every major hydrocarbon and renewable energy basin, from the North Sea to the Middle East, Australia to the Gulf of Mexico.
A company this large doesn't change direction easily, so this is a true strategic shift we're talking about.
It has to be, which is why the roots are so important.
Right. Before Baker Hughes was Baker Hughes, there were two distinct corporate empires, each founded on a single, brilliant mechanical innovation.
Yeah, we have to start between, 1907 and 1987. That's when these two separate giants were just revolutionizing how we accessed underground energy.
And it's fascinating how complementary their original expertise was.
It really is. The eventual modern company was born from the union of two really distinct specialties. One was mastering the sheer mechanical act of drilling the hole.
Okay.
And the other was perfecting the science of completion and production, making the wellbore secure and getting the fluid to flow efficiently.
Two sides of the same coin, really.
Exactly.
So let's start with the Hughes Tool Company, founded in 1908. We all know the name Hughes, right?
Mostly because of Howard Hughes, Jr.
The famous aviator, filmmaker, the eccentric billionaire.
Right.
But the actual foundational genius, it came from his father, Howard R. Hughes, Sr., working with his partner, Walter Benona Sharp.
And that foundational invention, the reason Hughes is still a household name in the drilling sector, was the two-cone drill bit.
So what was so special about that? I mean, what were they using before?
Well, before 1908, when you drilled for oil, especially with those early rotary rigs, you used what were called fishtail bits.
Fishtail bits, okay.
Yeah, they were essentially sharp pieces of steel that just scraped the rock. They worked okay, in soft sedimentary formations. But when you hit hard rock-like igneous or dense limestone, which you often find when you're trying to access deeper, older reservoirs, they just failed.
It just stopped.
They stopped. The drillers either had to give up or switch to the much, much slower, percussive cable tool method.
So the two-cone bit changed the fundamental physics of drilling.
Completely. Instead of scraping, Hughes and Sharp designed two rotating cones with hardened teeth, and they were positioned to roll across the bottom of the hole.
So they're crushing, not scraping.
They're shearing and crushing the rock simultaneously. This allowed rotary drilling to tackle those deeper, harder formations that were previously inaccessible. It unlocked vast new oil reserves across the entire globe.
The impact must have been immediate.
It was immediate and massive. It transformed drilling from a geographical gamble into a viable deep earth engineering project.
And the origin story is it's pure industrial folklore. You have to tell the anecdote of the Goose Creek secret in Texas.
It is cinematic, isn't it? Hughes Sr. was paranoid about protecting his intellectual property.
And for good reason.
For very good reason. This technology was revolutionary. So he conducted the first two tests on a drilling rig in Goose Creek, and he'd physically request the entire drilling crew to leave the area.
No way.
Brought the prototype bit out of a locked wooden box and conducted the operation in total privacy with only his trusted associates.
So what happened?
Well, the first run was not without drama. The drill pipe actually twisted off, which kind of highlights the massive forces at play here.
Sure.
But the second test was an unqualified, spectacular success. It demonstrated the bit could just chew through rock that had previously stopped drilling cold.
And that led to the patent.
It led to the founding of the Hughes Tool Company in 1909, and the patent was granted to Hughes on August 10th, 1909.
And the scale started very small, as most great industrial firms do.
Tiny. Their first dedicated manufacturing shop was just a 20-foot by 40-foot rented space.
And then, in 1912, Sharp passed away.
Right, and Hughes Sr. bought out his partner's share. The company was officially renamed Hughes Tool Company in 1915.
This is where the narrative thread gets complicated.
Very. Hughes Sr. died unexpectedly in 1924, and the company was inherited by his son, Howard Hughes Jr., who was just 19 at the time.
And the junior Hughes was, let's say, famously uninterested in manufacturing tools.
Not at all. His passions were in aviation, film production, and ultimately a reclusive life.
So who ran the company? I mean, who kept the lights on?
It's a great example of the technical expertise and management depth that existed independent of the owners. Astute managers in Houston, particularly Fred W. Ayers and Maynard Ellsworth Montrose, they kept the company growing.
So they were the ones who insisted on continued R&D and international expansion.
Mm-hmm. They turned the company into a cash machine that, fueled Hughes Jr.'s increasingly expensive hobbies.
And they kept the intellectual property flowing.
Constantly. The two-cone bit was great, but they kept improving. In 1933, they introduced the tri-cone drill bit. It refined the original concept, spread the load, and just ensured a smoother operation.
And then came the really big leap in efficiency in 1959.
The self-lubricating sealed bearing rock bits. Yes.
That detail about the sealed bearings is so critical for you to understand. Before that, the bearings on the cones would rapidly wear out because of the abrasive drilling mud in high heat.
Right. And when the bearings failed, the bit was useless.
So you had to stop drilling, pull the entire string of pipe out of the hole, which could take hours or even a full day on a deep well, just to replace the bit.
It's what the industry calls non-productive time, and it's incredibly expensive. So sealed bearings dramatically extended the bit's life, reducing that non-productive time and just cutting costs tremendously.
Precisely. And they were pioneers in the science of efficient drilling, not just the tools themselves.
That's right. They opened an enlarged engineering and research laboratory in 1958. It had advanced instruments like a direct reading spectrometer, and they published the industry's first comprehensive guides to efficient drilling practices in 1960.
So they transitioned from just selling hardware to selling an engineered solution.
Exactly. And then in the 1970s, Hughes Tool began its acquisition spree. In 1978, they acquired Brown Oil Tools, which had been around since 1929, and crucially patented the first liner hanger in 1937.
Let's pause on the liner hanger for a moment because this is an essential completion technology.
It really is. So when you drill a deep well, you continuously run casing pipe down the hole to prevent the well bore from collapsing.
Okay.
But running that pipe all the way back to the surface becomes incredibly expensive and heavy. A liner hanger allows you to hang a new, shorter string of casing aligner from the bottom of the previous larger string.
It saves time, material, and structural weight.
Yes, which is particularly important for offshore platforms. So by acquiring Brown, Hughes bought critical completion expertise.
They also expanded into drilling fluids, or mud. In 1979, Hughes Tool acquired Oil Base Inc., or OBI.
And they were pioneers in specialty drilling fluid additives. They famously introduced Blackmagic SFT in 1949, a product still sold today.
And what did that do?
This additive was used to free pipe when it got stuck in the hole, which is a very common and very costly operational issue. So Hughes was moving beyond just the bit and into the entire downhole ecosystem.
Okay, so that's pillar one.
Now we turn to the second pillar. Baker Oil Tool Company, founded around the same time, starting in 1907.
And if Hughes was the mechanical innovation focused on destroying the rock,
Baker was the completion engineering genius focused on securing the wellbore.
and the founder, Reuben C. Baker, is one of those incredible stories of American ingenuity.
Oh, absolutely. The sources show he was a farm boy, only 3 years of formal education.
3 years.
Yet he went on to receive over 150 patents in his lifetime. He started in the oil patch in 1895, just hauling oil, and by 1896 he was a drilling contractor himself. He saw all the problems firsthand.
His core revolutionary invention, patented in July 1907, was the casing shoe.
And this was monumental, especially for the cable tool drilling techniques that were so prevalent then. When you run casing into a well, especially through unstable formations, debris can fall into the bottom and block the pipe, or the casing itself can get damaged.
So the casing shoe goes on the very bottom of the casing string.
All right. It has specialized guides and often features a float valve. Its purpose is basically threefold:
Yeah.
to guide the casing past obstructions, to protect the bottom edge of the pipe from damage, and most importantly, to allow the efficient running and subsequent cementing of the casing.
Which ensures the uninterrupted flow path for the oil once the well is perforated.
Precisely. So he established the Baker Casing Shoe Company in 1913, but he quickly realized the potential for a much broader range of downhole tools.
So by the 1920s, they were aggressively expanding.
hmm They established a critical Houston base and changed the name to Baker Oil Tools, Inc. in 1928, reflecting a product line that was now focused on cementing, fishing, which is retrieving lost tools, and other completion equipment.
Their growth continued through the mid-century, and it was driven partly by necessity. The Model D Packer was introduced in 1942, partly spurred by steel shortages during World War II.
The Model D Packer was key because it enabled multiple completions in a single well bore.
What does that mean exactly?
Before, you might need several different wells to produce from different geological zones. A packer seals the annulus, that's the space between the casing and the production tubing, and it allows engineers to isolate specific zones for selective production, testing, or treatment.
So it's a massive leap in efficiency.
It's huge. It earned the company the prestigious Army-Navy E-flag in 1943 for their wartime manufacturing contributions.
Baker himself retired in 1956 and passed shortly after.
But the company culture he built, focused on relentless patents and acquisition, just continued. By 1976, the company was large enough to rebrand as Baker International Corporation, consolidating its massive portfolio in Houston.
And we see that same aggressive acquisition strategy mirroring Hughes' tool.
Oh, yeah. In the 1960s, Baker International acquired Pressure Services in '62, and then Kobe in '63, which manufactured high-tech hydraulic systems for oil well pumping. They were diversifying beyond passive tools into active downhole equipment.
And crucially, they solidified their completion expertise by acquiring Lines, Inc. in 1970, which produced,
Liner hangers.
you guessed it, liner hangers, a key technology they now shared with their future merger partner, Hughes. The market was clearly demanding these comprehensive solutions.
But the acquisition that truly broadened their scope was Miltim in 1971.
A major drilling fluids provider.
Right, tracing its history back to the 1930s. And drilling fluids are the lifeblood of the drilling process. They lubricate, cool the bit, control formation pressure, and they carry cuttings back to the surface.
So Milcom provided the chemical expertise that complemented Hughes's mechanical expertise.
Exactly. And the need for knowledge just kept pushing them. In 1972, Baker International acquired Exploration Logging Company, or XOG.
XOG specialized in mud logging.
Right. As the mud returns to the surface, technicians analyze the physical and chemical properties of the rock cuttings and the gases carried up. This provides real-time geological information.
Like where you are, what pressures you're seeing, and most importantly,
If you're hitting oil or gas. XOG was founded in 1952 in California, and its acquisition shows Baker's shift toward integrated information services, not just hardware sales.
So, stepping back for a minute, what we're seeing here is two massive companies building these complementary empires through internal innovation
The bit and the casing shoe.
and then aggressive external acquisition. They were both aiming for total vertical integration of oil field services.
The stage wasn't just set for a merger, it was set for an inevitable collision, especially when the economic environment changed so dramatically.
That collision finally came in 1987. The 1980s oil glut had created tremendous market pressure. Oil prices collapsed, and suddenly the cost of competition became unbearable.
Yeah, when prices fall, the efficiency of oilfield services becomes paramount. And the best way to achieve radical cost reduction and leverage market dominance is through consolidation.
Which led directly to the birth of Baker Hughes Incorporated.
Baker International merged with Hughes Tool Company in a stock transaction valued at $728 million.
But as you pointed out, this was less of a smooth partnership and more of a shotgun marriage driven by survival. The merger was fraught with drama right from the beginning.
Oh, it was contentious because the merger created such a huge market share in several crucial tool categories. Regulatory bodies,
The DOJ,
specifically the U.S. Department of Justice, they demanded concessions to prevent monopolization. Baker had to enter into a consent decree, which forced it to divest significant product lines.
including Reed Tool Company, which Baker had acquired back in 1975 for $120 million, and its Baker Lift division.
And here's the dramatic turn. Hughes actually attempted to terminate the agreement after Baker had already begun the process of divesting these profitable businesses.
Why?
They argued that the divestitures materially changed the value proposition of the deal.
Which led to Baker suing Hughes for $1 billion just to force the deal through.
Can you imagine? Despite the legal battles and all the acrimony, Hughes shareholders voted overwhelmingly to complete the transaction, forming the modern Baker Hughes Incorporated.
This contentious start is, I think, highly indicative of the company's culture. They have been forged in this crucible of relentless M&A, legal battles, and forced adaptation.
It definitely prepared them for the nonstop structural reshaping that continues to define them today.
And this brings us right up to the current structure, which underwent a major simplification post-2022. This reorganization is critical because it explicitly signals their future priorities.
That's right. The company is now organized into two primary operational units.
The first and the largest pillar is what they call Oil Field Services and Equipment, or OSE.
This is the traditional cash engine. It covers the entire life cycle of a well. The drilling, the completion, the intervention, the production, subsea systems, the flexible pipes required to move the fluids, all of it.
But the nuance here is where the pivot begins subtly. The OFSE segment explicitly serves both the petroleum and the geothermal industries.
And that's a huge strategic insight. Geothermal energy involves drilling extremely deep wells to access reservoirs of high-temperature heat or steam.
So they are tapping into the Earth's core energy, not hydrocarbons.
But wait, how much of that century-old drilling technology actually applies to geothermal? I mean, are the temperatures and materials not wildly different? Is this a genuine leverage point, or is it just good marketing?
That's a fantastic point to probe. The core expertise managing high-pressure environments, dealing with directional drilling deep underground, handling corrosive materials, it's all completely transferable. However, you're right, geothermal temperatures are significantly higher, sometimes reaching over 300 degrees Celsius. That stresses electronics, elastomers, and metallurgy far more severely than standard oil and gas drilling. So Baker Hughes is banking on the fact that they have the best tools for drilling deep, difficult holes, regardless of the fluid coming out. It's an effective way to diversify risk without abandoning their core competencies.
But the real shift, the genuine redefinition of the company identity, is housed in the second pillar.
The Industrial and Energy Technology, or IET segment.
Right. This segment is where the future capital investment is focused. It provides high-tech equipment for mechanical drive, compression, power generation, and specialized measurement tools.
But the strategic focus is squarely on climate-related technologies. This includes the equipment and infrastructure needed for carbon capture, hydrogen production, and sophisticated emissions management solutions.
So if the OSE segment is leveraging their legacy to keep the lights on,
The IET segment is explicitly designed to future-proof the company.
yeah, the skills they developed managing massive compressors for LNG or natural gas pipelines are now directly applicable to compressing hydrogen or compressing CO2 for sequestration.
It's the organizational mechanism they're using to chase their net zero goals.
So that 1987 merger was, as we established, just the beginning of a new, even more aggressive phase of growth and specialization.
The goal was to dominate specific technological niches, and the 1990s were marked by massive strategic technology acquisitions.
One of the most pivotal deals was in 1990, the acquisition of Eastman Christensen for a whopping $600 million.
This wasn't about just getting bigger. This was about cornering the market on the next great technological leap in drilling, directional drilling.
Absolutely.
So explain the magnitude of that technological shift. What did Eastman Christensen bring to the table?
Okay, so directional drilling is the process of intentionally steering the drill bit to follow a specific non-vertical geological path. Eastman's lineage goes back to 1929 in California. They pioneered the use of whipstocks and magnetic instruments to deflect the pipe. And then later, the Christensen side brought advanced diamond bit technology and, critically, downhole motor innovations like the knobby drill line.
So this wasn't just about pointing the bit in a different direction. It was about precision.
Total precision. They developed the industry's first truly steerable motor system and the revolutionary AutoTrack rotary closed-loop system.
And that was a quantum leap.
A quantum leap. The AutoTrack allows the driller to continuously rotate the drill string while steering. That eliminates friction and allows for much longer horizontal wells.
Before you had to stop rotating the pipe to steer.
Right, which created friction and limited the length of the lateral section. This technology unlocked the age of horizontal drilling that completely dominates fracking and deep reservoir development today.
That kind of dominance came at a price, though. The acquisition process itself revealed the necessary ruthlessness of M&A.
It did. To secure U.S. Department of Justice approval for the Eastman Christensen deal, Baker Hughes was forced to sell its own Hughes Tool diamond bit business.
Wow. So they effectively sold off a piece of their legacy technology to acquire a far superior suite of directional drilling and measurement tools.
They did. The combined entity was named Hughes Christensen.
And the innovation under Hughes Christensen didn't slow down. They introduced the AR series PDC bits in 1993, claiming penetration rate increases of up to 100%.
And by 95, the Gold Series PDC line focused on reducing frictional forces. They were continually building on the Genesis HCM bits with patented easy steer depth of cut control, making the drilling process highly automated and efficient.
The next piece of the puzzle was real-time information.
Right. They moved into measurement wall drilling, or MWD. In 1992, they acquired Teleco Oilfield Services for $200 million. Teleco was the provider of the world's first MWD tool, introduced back in 1978.
So why is MWD so valuable, especially when you pair it with directional drilling?
Because MWD transmits real-time data from the drill bit back up the pipe to the surface using pressure pulses in the drilling fluid without having to stop drilling.
And this data includes the direction, inclination,
and crucial formation properties. If you're drilling a horizontal well, MWD is your eye downhole. You can steer the bit to stay precisely within a thin layer of reservoir rock, maximizing exposure to the hydrocarbon.
Without MWD, you would be operating blind.
Totally blind. Constantly pulling the pipe out to check your position, which is incredibly costly and time-consuming.
This accumulation of integrated services, directional drilling, advanced bits, real-time measurement led to another corporate shuffling moment in 1993.
Right, creating Baker Hughes InTQ to combine 5 of the company's oil field divisions. It's just this perpetual state of corporate synthesis.
And that strategic push reached its peak in the late 1990s with the colossal 1998 acquisition of Western Atlas.
This was massive, $5.5 billion in stock, plus they assumed $700 million in debt.
And Western Atlas was the final piece of the integration puzzle. It brought expertise in seismic data and downhole wireline services.
It did. And here's where it gets really interesting on the corporate rivalry front.
They spent billions just to keep it out of Halliburton's hands. That sounds like a Cold War mentality in the oil patch. How did that shape the culture of the combined company?
It absolutely was a defensive, existential, strategic move. Western Atlas was a strong competitor specializing in subsurface imaging. Seismic uses sound waves to map geological formations, helping companies decide where to drill.
Yeah.
And wireline services use cables dropped into the well to take precise measurements and logs. So by acquiring Western Atlas, Baker Hughes gained robust capabilities in seismic data and downhole logging, matching the full spectrum of services offered by Schlumberger and preventing Halliburton from gaining a significant advantage.
It showed a willingness to pay a premium to ensure competitive parity.
A huge premium.
So what happened to that massive seismic business?
Well, it didn't last. In 2000, during an industry downturn, Baker Hughes merged its Western Geophysical division with Schlumberger's Geico to form Western Geico.
An attempt to reduce capital expenditures.
Right, in the high-cost seismic market. But by 2006, Baker Hughes decided to exit the highly cyclical seismic data business entirely, selling its 30% share of Western Geico back to Schlumberger for $2.4 billion in cash.
It shows that even massive strategic alliances can be treated as temporary assets to be monetized when the market shifts.
Exactly. From data acquisition toward higher margin downhole services.
So while they were growing rapidly, this aggressive expansion into new, high-stakes international markets also brought significant corporate complications. Most notably, the 2007 guilty plea regarding the Foreign Corrupt Practices Act, or FCPA, violation.
This is a sobering reminder of the ethical and regulatory risks involved in securing massive international contracts. The violation covered activities from 2001 to 2003. The company pleaded guilty and agreed to pay $44.1 million in fines and penalties.
And this was linked to commission payments related to a major oil services contract for the Karachaganak field in Kazakhstan.
Correct. The $4.1 million in improper payments were funneled through consultants to allegedly help secure that lucrative contract.
When we discuss high-stakes international energy contracts, the complexity and the scale of the financial rewards often invite these serious ethical lapses.
which companies then spend years and millions of dollars resolving through deferred prosecution agreements. It shows that maintaining global dominance requires rigorous internal compliance, which is a constant challenge for firms operating in high-risk regions.
On a different front, but still related to global operations, we saw friction in their labor relations, particularly in Norway, a critical North Sea operating base.
Yeah, in June 2012, trade unions like SAIF threatened strike action involving 114 employees across multiple installations.
The threat was serious because even a small localized strike can shut down complex offshore operations, incurring huge costs.
Right. Fortunately for the company, the strike was called off quickly after the parties successfully agreed to a new collective agreement.
It reminds us that for a technology firm to operate smoothly, the human element managing thousands of employees under various collective agreements globally is as critical as the technology itself. Now, let's fast forward to the failed mega merger of the mid-2010s. This is a proposed acquisition by their major rival, Halliburton.
Announced in November 2014, valued at $34.6 billion.
That would have been the single largest merger in the history of the petroleum industry. It would have created an unchallenged global services behemoth.
And the stockholders of both companies approved it. That reflects the internal drive to consolidate during a period of global oil price volatility. The industry felt consolidation was necessary to control costs and exert pricing power.
But the U.S. Department of Justice wasn't having it.
Not at all. The DOJ sued to block the transaction in 2016. They had serious concerns that the merger would lead to a near monopoly in specific critical markets.
Not just broadly in oil field services, but in highly specialized niches.
Right, like deep water cementing, specialized directional drilling tools, and certain types of drilling fluid systems. They argued that competition would be severely harmed, leading directly to higher prices for the remaining E&P companies.
And the companies formally terminated the deal just weeks after the lawsuit was filed. So, having failed to merge with their largest competitor, they quickly pivoted their focus to a completely different type of partner, General Electric.
A huge pivot. They successfully merged with GE Oil and Gas in July 2017.
And this GE chapter fundamentally reshaped the company. It provided access to GE's capital, its industrial scale, and its advanced turbine and compressor technology.
The combined entity initially took on the name Baker Hughes, a GE company.
And even this successful merger required regulatory concessions.
It did. To satisfy regulators, Baker Hughes sold a significant portion of its hydraulic fracturing and cementing business, a segment that included the previously reacquired BJ Services Company, for $325 million.
So that was the cost of marrying into GE, shedding core, traditional services to integrate GE's industrial technology portfolio.
Exactly. And in a final twist of corporate churn, even the GE alliance proved temporary. GE subsequently announced plans to divest its entire stake by 2023, refocusing on its core industrial and healthcare businesses.
So by the end of 2021, GE's ownership had already plummeted.
It had. And the company that emerged from the GE chapter was the Baker Hughes company we see today, aggressively independent, focused, and armed with the technologies it gained during the merger.
And now clearly focused on energy transition.
That GE divorce coincided precisely with the global escalation of climate targets, forcing the company to decide how to leverage its massive infrastructure for the future.
And the answer lies in that industrial and energy technology, IET segment. It's become the primary vehicle for this pivot.
The first step was establishing clear, externally facing climate pledges. They made a significant commitment in January 2019
to reduce carbon dioxide equivalent emissions by 50% by 2030. And to reach 100% net zero emissions by 2050, using a 2012 baseline.
And these aren't minor adjustments. These are huge, public, decade-spanning targets that demand radical investment.
And they back those pledges up by chasing the most difficult technological challenge in the energy transition, industrial-scale carbon capture technology.
Right. This involved both licensing external expertise and acquiring specialized firms.
They moved quickly. In November 2020, they acquired Compact Carbon Capture. What was the significance of that?
Compact Carbon Capture focused on developing solvent-based carbon capture patents. Solvent-based systems are the most established method for stripping CO2 from industrial flue gases.
So they use liquid chemicals, solvents that chemically bond with the CO2.
Exactly, which is then released and captured by heating the solvent. This was a direct entry into a crucial decarbonization market.
And following that, in March 2021, they secured a license for the use of mixed salt process technology, or MSP, for flue gas carbon capture from SRI International.
So the MSP technology is a parallel competing methods for CO2 capture. It's often cited for its lower energy demands when dealing with high-volume, low-concentration flue gases.
Like those from certain power plants or large industrial facilities.
Exactly. So by acquiring both the solvent-based systems and licensing MSP, they are strategically pursuing multiple technological pathways to build a comprehensive, full-spectrum carbon capture portfolio for their clients.
And this commitment is translating into real-world projects, not just patents. In June 2021, they entered into a joint venture with Borg CO2, specifically targeting a waste-to-energy plant in Sarpsborg, Norway.
That project is key because it moves them from laboratory or pilot-scale work to practical, large-scale deployment. They are tasked not only with capturing the CO2, but also with engineering the infrastructure for its liquefaction.
Cooling and compressing the gas into a liquid state.
Right. And transportation to a final sequestration site. This is a complete CCUS carbon capture, utilization, and storage chain solution.
Beyond carbon management, they're looking at the fundamental components of energy infrastructure. We saw a major joint venture in December 2020 with Aramco to create novel non-metallic solutions manufacturing.
This is all about modernization and materials science. The goal of Novel is to produce advanced non-metallic materials like high-grade composite pipes and equipment.
And why is that important?
Well, non-metallics offer superior resistance to corrosion compared to traditional steel. They weigh less, and they can significantly lower maintenance costs. This is particularly relevant in the Middle East, where high sulfur content often accelerates pipeline decay.
And it will be crucial for handling highly corrosive fluids like wet CO2 or future hydrogen blends.
You got it. Their strategy also shifted heavily towards software, services, and asset integrity, the knowledge economy side of energy management.
Which feeds directly into the IET segment. In 2021, they acquired RMS Reliability, providing advisory services and software across several industries.
ARMS focuses on predictive maintenance and operational efficiency. Instead of waiting for a pump or compressor to break, their software uses data analytics to predict failure, allowing for planned maintenance.
This is a high-margin business that increases the efficiency and safety of massive infrastructure.
And it's a crucial component of emissions management, as efficient operations inherently reduce waste and consumption.
That knowledge focus was cemented in November 2022 with the $279 million acquisition of Quest Integrity.
Quest Integrity provides critical asset integrity services. They make sure that aging infrastructure pipelines, refineries, storage tanks remain safe and operational using advanced inspection technologies and data analysis.
These types of acquisitions are not flashy, but they are essential for integrating high-tech, high-margin services into the overall portfolio.
Right. It moves them away from being merely a tool provider to a full-service technology manager.
And while the IET focus is clear, they haven't abandoned the core drilling and intervention services.
Not at all. In March 2021, they announced a joint venture with Acaster ASA's subsidiary MH Worth AS, focused on global offshore drilling solutions. And in March 2022, they acquired Altus Intervention, a Norwegian oil well specialist, strengthening their well intervention position.
These moves show the balanced strategy. They're still optimizing and consolidating their core OSE business to generate the necessary cash flow and maintain market leadership.
Which, in turn, funds the massive R&D and M&A required for the IET pivot.
And that M&A strategy culminated in the most significant indicator of their IET commitment, the massive announced acquisition of Chart Industries in July 2025 for $13.6 billion.
This is the definitive strategic shift. Chart Industries is a specialized manufacturer, recognized globally as a powerhouse in industrial gas processing, liquefaction, and cryogenic technologies.
And cryogenics is the science of extremely low temperatures.
Right. Often used to turn gases into liquids for storage and transport.
So why does this acquisition, valued at $13.6 billion, instantly change Baker Hughes's competitive position?
Because it provides the essential high-tech hardware required for both the hydrogen economy and large-scale CO2 management. Hydrogen must be liquefied at extremely cool temperatures, around minus 253 degrees Celsius, to be economically transported and stored.
And CO2 must also be highly compressed and often liquefied for injection into sequestration wells.
And Chart provides the necessary turbo machinery, heat exchangers, storage tanks, and specialized compression systems.
So by absorbing Chart, Baker Hughes instantly acquires decades of specialized expertise in industrial cryogenics. They go from being a hopeful participant in the energy transition to a fully integrated technology provider.
Right. capable of delivering the entire infrastructure for CCUS and hydrogen projects, challenging established industrial gas players like Linde or Air Products.
It accelerates their pivot by years, arguably making the IET segment equal in future importance to the Helvesi legacy business.
The journey from the two-cone bit, invented in a rented 20 by 40-foot shop, to a company focused on cryogenic liquefaction for hydrogen it's remarkable.
It's a story of constant reinvention, driven by the singular goal of efficiency and dominance.
Yes.
So what does this all mean for you, the listener?
Well, if we connect this to the bigger picture, the modern Baker Hughes is a synthesis of genius-level mechanical innovation at its root and relentless surgical corporate consolidation. They have mastered not only drilling deep holes, but the data, the chemistry, and the materials needed to manage those holes efficiently.
And the modern structure explicitly signals an intent to move beyond just oil services into becoming a holistic energy technology company.
Right. Focusing on geothermal, precision measurement, and critically, emissions management.
The final takeaway for you is that the journey of Baker Hughes is a powerful story of corporate adaptation, from being defined by revolutionary iron tools in 1908 to being defined by climate-focused software, high-pressure compression, and cryogenic technology in 2025. It's a blueprint for how a legacy energy company attempts to future-proof itself by strategically deploying vast amounts of capital.
This raises an important question that you should keep in mind as you watch the energy sector evolve. Considering the company's long history of aggressive acquisition and contentious mergers, especially the massive 2025 purchase of Chart Industries, how quickly can a company built on a century of traditional petroleum services truly pivot its core identity and massive operational infrastructure to deliver on its ambitious 2050 net zero emissions pledge? The challenge isn't the technology, which they now own. It's the execution and the cultural shift required to deploy it at global scale while simultaneously managing the decline of their legacy business.
A challenge for sure, and one that will define the next decade of the energy market. We will certainly be watching. Thank you for joining us, and we'll catch you on the next Deep Dive.